Okay, 3.6, perpendiculars and distance. This is pretty short notes. Basically, the key concept that we're trying to get here is that the shortest distance from any point, so we got a point C here, to a line, and here's a line AB, is always going to be perpendicular to that line that we're trying to approach. So it's always going to be at a 90-degree angle. So you got all these other lines, but you can tell that this distance here is the shortest distance. It's shorter than any of these lines. So that's it. You just need to know that that is the shortest distance. So a lot of times they're going to ask you to do things like draw a segment that represents the shortest distance from point A to BC. Well, BC is way over here, but what you can do is you can extend this line, BC, and obviously I'm on my iPad, so it's not as easy to do as on paper, but you can extend that line, and then you could draw straight down from A at a right angle, and so that's going to be your shortest distance from point A to the line BC. Because just because BC only goes from here to here, there still exists a line that goes beyond that. So BC is a segment of a line that goes on and on and on forever. So you can still touch the line segment, the line BC, even though you can't touch the segment BC. That's how you do that. So go ahead and just try these ones on your own. Pause the video and see if you can do these ones on your own. Okay, if you did it on your own, you should have gotten something like this. Again, you just extend BC and drop it straight down at a right angle. Extend QR, drop it straight down at a right angle. And that's primarily what your homework's going to have you do. Okay, on to the next problem. Okay, some of your harder problems are going to look like this guy. There's going to be a couple like this. And basically what they're asking you to do, you're going to need a compass for this. They're going to ask you to construct a line perpendicular to line L through -6, -9, and 0, -1. So here's line L right here. And we want to go through this point, -7, -2. So let me zoom way in. And here's that point right here. So that's -7, -2. Well, we need to construct a line that is perpendicular. So what I'm going to do is I'm going to show you what the compass should look like. Now this is just an estimation. What you would do is you would take your compass and you would open it up to this point. In fact, I wonder if I can just use an arrow here. Oh yeah, here we go. Okay, so we can take this having a little trouble getting this to work. Okay, I couldn't really get that to figure out. But what you would do is you'd start with your compass right here on -6, -9, and you would open it up to this point here, -6, -2. And then, with your compass open up to that distance, you would bring it around and draw an arc out here. Then you do the same thing. So your arc would look, and again, this is just kind of a faint example, but it would look something like that. Then you're going to open up your compass put the metal point right here, and put the pencil part right here, and make another arc out here. Okay? So again, that would look something like this. And then wherever this intersection point is, and mine may be way off because I didn't really use a compass. All I did is just kind of freehand it. But then wherever your intersection point is here, you're going to connect a line to that guy right there. So let's make a line. Okay, I tried to do my best to show you what the line should look like here. But it's going to go through this point here and this point down here that your intersection is. And if you did it right, if you did just right, it should go through this point right here, which should be -3, -5. So if you did it right, that is where your whole construction should end up. And I know it's kind of confusing. This is kind of hard to show over the iPad. But give it a shot, and if you can't figure it out, just come in and see me. But you get it right there at that point, -3, -5. And now you have a distance here to here. And that's what they want you to figure out. They want you to figure out what the distance was from this point to this line. And the reason why we did all these constructions and everything is because that gives us a perfect right angle right here. And so we know that this distance here is the shortest distance from the point to a line. And that's always how we find the distance from a point to a line, is we calculate the shortest distance. Well, now that we have the shortest distance here marked, we can actually take the distance formula and try and figure out what the distance is from one point to the next. And so in order to do that, first we want to label our points x1, y1, x2, y2, and we're going to plug that into the distance formula, which remember is x2 minus x1 squared plus y2 minus y1 squared. So when everything gets plugged in, it should look something like this. x2 is negative 3 minus a negative 7 squared plus y2, which is negative 5, minus a negative 2 squared. And whenever you get a negative times a negative, remember we turn that into a positive, and we turn that into a positive. Okay, so I'll move that right over here. See if this gives me enough room to finish this problem. We could say negative 3 plus 7 squared. Well, that's the same thing as positive 4 squared. And negative 5 plus 2, that's the same thing as negative 3 squared. 4 squared is 16. Negative 3 squared is 9. Rad 25. So this is 5. Okay, so that means the distance from here to here that we were trying to calculate is simply 5. And so we found the distance from a point to a line. We did it. And that's what they were having us do this whole time. If we look back here, I'm going to shrink this down, throw it off to the side. But remember, they just said construct a line, perpendicular line L through all these points, then find the distance from point P to L. This was our point P, negative 7, negative 2, to the line. And that's what we did. Okay. Lastly, I just wanted to read this key concept to you. It says the distance between two parallel lines is the distance between one of the lines and any point on the other line. So if I wanted to find the distance between these two lines, I could just pick any point on this line and then find the distance from that point to this line the same way we just did on the previous problem. And that would actually give me the distance between the lines, as long as all these distances are right angles, which they will be if we construct perpendicular lines. So I don't think you're going to have a lot of problems like that, but just a little concept that I'd like for you guys to be aware of. Lastly, summary: to find the shortest distance between a point and a line, at what angle must the segment be from the point to the line? Acute, obtuse, right, and why? And if you are, hopefully the answer for the angle part is obvious, but if you're wondering why, take a look on the first page. Top of the first page, there should be some hints to why that's important. Okay, that's it.